right, recording started. Today's lecture, we will continue on the circuit breakers. So in the previous lecture, we mentioned about several types of circuit breakers. We mentioned that there is like oil circuit breaker. There is also the SF6 circuit breaker, which is based on the material inside it, like it can be air. Use the air for cooling the medium, or for the medium for cooling the arc or to absorb the arc. Then we have the SF6, and the SF6 we mentioned it's very common in high voltage and extra high voltage, whereas like the insulation for the SF6 around 425 kilovolts per centimeters. Then we mentioned also the vacuum circuit breaker. So the vacuum breaker basically uses the vacuum to extinguish the arc. And the good thing about the vacuum, which is they have a long life, there is no fire hazards, and they are more environmentally friendly, more than the SF6, because the SF6 is a greenhouse gas, which is basically impacting the environment, while the vacuum is safer for regarding to the environment and longer life. Therefore, we prefer to use the vacuum circuits, but keep in mind that vacuum circuit is only common on medium voltage. Most likely you will see it in 33 kilovolts and 11 kilovolts. However, in high voltage and extra high voltage, we are using this one. High voltage and extra high voltage, we will use SF6. We cannot use a vacuum in the high voltage and extra high voltage. The main reason because the insulation in the um, again SF6 is more regard, while the vacuum tube is less, has less insulation. So this is how the vacuum looks like. Then the next thing, which is basically we'll talk about the arcing and the circuit breakers. So during opening, when the circuit breaker opening, um, it will be ionized within the contacts. The material within, or the contacts, the material between them will be ionized. Therefore, or in other words, I would say like the medium contacts will be ionized, will create an arc. So here is like the contacts. So when we open the circuit breaker, when start opening, the media will be ionized here, will conduct electricity. This will cause an arc, will create a big arc. That arc we need to extinguish this. So if that arc remains, the current keeps flowing, which will make deflecting on the circuit breaker purpose, which will make the circuit breaker conducting electricity. So the goal is to extinguish this arc as quickly as possible and to reach a zero currents. So we want to reach this stage where there is nothing connected. No. So even if it's here ionized, if it's here ionized, there is no arc between them. That's our target. So when we open the contacts, it will make no arc. So again, due to the large power, there will be, when we move the contacts between the moving and the fixed contacts, there will the arc will be conducting electricity, while we need to remove or to absorb that the what's called absorb the cylinder. Again, we need to absorb the that arc, so there will be no arc at the end. Therefore, depending on the medium, so the medium, as we said before, it can be air, which can be oil, SF6, and vacuum. Most likely air is used in low voltage, some of medium voltage. Oil, it can be in medium voltage. SF6 can be extra high voltage, and medium voltage, but not common in medium voltage. Vacuum is more common in medium voltage. While SF6 less common in medium voltage. Okay. The overall principle about the arcing, which is when we open, during the opening, the current carrying contacts of the breaker, the medium will be ionized. So this provides a low resistance path for fault currents continuous, and during the flow of the currents from one contact to the other, the arcing medium is heated and then glows. This is called the arc. This is as an example of the arc. Here, even though it's in the isolators, this is not in the circuit breakers, this is in isolators. But here, when there was a circuit breaker failure and the isolator is opening, so there is two moving contacts. These moving contacts, once they move, it will produce a big arc like this because the air is ionized. Since it's ionized, it will cause that big arc. And the arc can cause some problems, in especially like for example here in medium voltage level, it can make some permanent damages or sometimes can make some collision or explosion. That's something that we don't want, but we have it. We do have it. Then we need to make sure to move that effect as much as possible. So whenever the contact of the circuit breaker is open, there will be an arc inside between the contacts. The arc, if it's not continued, then the current continues through the circuit breaker, which is the fault keeps going. The fault currents keeps flowing. And by the way, the main reason for opening the circuit breaker is because there's a fault current. But if the fault current keeps flowing, which is a very big current, that can cause some damages. So which is again defeat the purpose of the circuit breaker, then cause some permanent damages. Now, for proper working, we need to make sure to kindle and extinguish that arc as quick as possible. So the main thing to do that is to make sure the circuit breaker safe, fast current interruption by arc tuning as much as possible. So operation of oil circuit breaker. So when contacts separated in oil, the arc ionizes the oil and forms gas bubbles. These gas bubbles rise and compress, increasing the dielectric strength and helping it to extinguish the arc. So that's the thing. There will be some gas bubbles that make the extinguishing the arc and cause the arc extinguishing. Then there will be the electric strength between the contacts increases, which will eventually continue the arc. So the overall thing about it, oil, there will be gas bubbles. These gas bubbles will extinguish the arc. Here is how it looks like again. This is a fixed contact which is not moving. This is the moving contact. So it used to be here. Then after that, it's been shifted. Then keep going, shift it to this way. When we shifted it to this way, this is the arc, and the gas will be ionized. Since the gas is ionized, it will cause gas bubbles. These gas bubbles will help and extinguish the arc. That's the overall about it. Now let's talk about the air circuit breaker. So the air circuit breaker, which is most likely this is common in low voltage levels, this is using the air to cool the arc. To cool or extinguish the arc. So it can here in the arc cooling, the arc plasma, which is as the temperature of the arc is decreases, the mobility of the particles in the arc plasma is reduced. Therefore, higher voltage is required to maintain the arc. So we need to make sure to make it cool and decrease the arc path. So as the length of the arc path is increased, the resistance of the path is increased. To maintain the same arc currents, higher voltage is required, splitting the arc into a number of series areas. Now the next thing, which is the SF6, using the SF6 um, to extinguish the arc. Now, how can we SF6? What's SF6? Which is basically it's called sulfur hexafluoride, or again, in other words, SF6. What's the meaning of SF6? And the SF6 has excellent insulation properties, where again, as we mentioned earlier, it used to be 425 kilovolts per centimeters. Then this gas has a high ability of absorbing free electrons whenever freeing electron collide with the SF6 gas modules. This is can this it's absorbed by that gas and forms a negative ion. That's something that we can have. The disadvantages of the SF6, it requires large mechanical energy, and a gas while that's one of the main drawback, require large mechanical energy. And the other thing, which is it's very harmful to the environment. So that's something is basically a big concern for us, which is that's why it leads the utility to reduce their usage as much as possible. That's why it's not used in low voltages, but right now, or even like in mid voltages, but they are used in high voltage and extra high voltage. Vacuum circuit breaker. So the vacuum circuit breaker, the good thing about it, which is it has the very long service life, no fire risk, and minimal environmental impacts. And they are very widely used in medium voltage application. While again here, SF6 is widely used in high voltage and extra high voltage application. However, when we talk about the air circuit breaker, this is very commonly used on not the oil, the air. The aerial circuit breaker will be used in low voltage. I'm not sure where is it located, but yeah, the aerial circuit breaker. We will use low voltage. Okay, those are as an examples of the SF6. You can see the vacuum circuit breaker as we see here. This is how it looks like. This is the control or the overall relay or the switch gear regarding to that circuit breaker. This is how we can see for regarding that. Then this is the overall room. That's where how we install it. You will see a controlling wiring sockets, the top shutter, the duct cover, top right, lower shutter, right hand travel rail, earth switch operation for mechanism and drive shaft. Then here in the back, you will see the control wiring block, with the drawable part, square spigot, earthing switch operating mechanism. Then this is how it looks like. Again, once you do the interlock, the currents will flow from here to here. Once we realize there is a fault, or when there is a circuit breaker is open, it will make enough distance between this and the contacts. So it will be like this. They will not touch each other. But if you need to plug it here. and so on for the remaining phases. Now here is also another type of the aerial circuit breaker, vacuum circuit breaker. This is how we install it. Then we need to make sure it is being mounted outside. We can push it outside. If it will be outside from the switch gear, if and only if the power equal to zero, or the currents is equal to zero. So if the circuit breaker is on, if it is not on and we pushed it out, it will cause an explosion, which is something undesired, and we don't want this. So we need to make sure we push it outside if and only if the power is zero or it's being tripped. If tripped. Here is how it looks like in the switchgear for the 33 kilovolts. You will see each line. So you will see this is a feeder, this is another feeder, another feeder, and so on. Everyone is a feeder. While somewhere here, you will see the 33 kilovolts transformer. Or I would say like all of them like the 33 feeders, and those are connected to the distribution company from converting low voltage or high voltage to medium voltage, which is basically converting 132 to 33 kilovolts. Even if we have 400 kilovolts, it will convert it to 132 kilovolts, then to 33 kilovolts. So all of them are feeders here. This is a feeder, feeder, feeder 1, 2, 3, feeder 4, feeder 5, etc. Now we will talk about the recloser. Let's recall in the previous lecture we mentioned about the type of faults. We mentioned it can be temporary, and we mentioned it can be permanent. So if the fault is temporary, temporary means happening for a very short period of time, like lightning strike, or one tree branch goes to the power lines. Then after that it goes. Then we need to make sure um, to distinguish if it's temporary or not. So what's the point of turning off the power for a very long period of time for no reason? Therefore, we will use the recloser to make sure that we need to use the recloser to re-energize the circuit breaker to distinguish if this is the fault is temporary or not. So basically, it will turn on, or the recloser will ask the circuit breaker to be turned on to check if that fault is permanent or if this fault is just a temporary and it will leave. So again, the recloser detects the overcurrent and automatically re-energizes the line after temporary faults, which is can operate, very short period of time or after a time delay to make sure the system takes their time. So three-phase reclosers protects all of the phases. Single-phase recloser avoids single-phasing issues. So here's how the recloser looks like. This is a recloser. So we will see that the recloser sequence, for example, here is the normal operation. Here is a fault. So when the fault's happening after a specific period of time, it takes some time, delta T0, to the fault current continues. Then here, circuit breaker trip. Then after that, we will re-energize it using recloser. Re-energize. Once you re-energize it, you will see the faults keep going. It's still false, the same as the previous scenario. Then, after a specific period of time, it will be tripping. Then, after the circuit breaker will be turned on again. So it takes some time. Let me rewrite it in a better way. I'm sorry. So this is normal. Here is a false. Then circuit breaker trip. Then here recloser. So when we have the recloser, the fault continues. Therefore, the circuit's tripping. Then after that, here like fault, here is normal, circuit breaker is off. I would say it's on. Here circuit breaker is on. Here circuit breaker is off. This is circuit breaker is off. Then here circuit breaker is on. Then after a specific period of time, we did the recloser again. So once we did the recloser again, there will be another false, so which means the fault seems to be permanent, not temporary. Then after that, circuit breaker will trip because the circuit breaker is on while the circuit breaker is off. Then after that, another recloser number 2 turning on. Then here we'll see a fault continues, and so on. The same scenario for here. We have the first stage. This is the normal operating condition. Faults happening. Circuit breaker is off, working. Then re-energize the circuit breaker. You will see a big current. Then the fault continues. Therefore, we will de-energize it. Then again, re-energize circuit breaker. There's still a big fault. De-energize it. Then do it, and so on, until reaching the maximum. So the thing about it, there is 0, 15 to 45 sequence. What are those? Basically, we will say the first recloser at 0 cycle. Then second recloser at 15 degrees, while third recloser at 45 degrees. I'm sorry, 45, I mean cycles. Sorry. Okay, so here is how we have 3 recloser attempts. Once it's being consumed, then the fault will be understandable as permanent. Then it's no longer temporary. It's going to be permanent. Therefore, the circuit breaker will be tripped after the third time, and that's all. Sectionalizer. So sectionalizer does not interrupt faults. It's instead it counts how many times that the recloser will operate. If the fault is permanent, the sectionalizer open while de-energize the isolated faulted sections. So the main reason for that is to isolate the again to isolate the faulted sections. Again, let me write it. Sectionalizers isolates the fault section. What does it mean? Sometimes assume here is the distribution generator, distribution transformer. Then it goes to this feeder. Then it goes through feeder 1. Then from that feeder 1, it can be absorbed like feeder 1, 2, and feeder 2, 1. Feeder 1, 1, and 1, 2. Then what's happening? There should be a sectionalizer to distinguish if the fault is at F11 or F12. So we don't want the whole F1 circuit to be tripping if the fault going on. We need to make sure to be either F11 or F12 to take care of it. So keep in mind the isolator, sectionalizer, counts how many times the recloser operates, and if the fault is permanent, the sectionalizer open while de-energize the isolating the faulted system. So, I mean, it's isolated the fault section. It is not a protection device. This is not a protection device to be turned on or off at fault conditions. While the thing it will operate, if there is fault in some area, then we need to isolate it from the rest. So not to minimize or reduce the number of impacted customers. Fuse switches. So there are used in low voltage industrial switchgear to protect motors, cables, and panels. And also, it's in your homes as well. They are combining switching capabilities with a fuse protection. So air breaker disconnect switches, which sometimes we call it isolators. And we're already aware of this before. Isolator, again, when we turn the power on and the power off, there will be, if there is a load condition, there will be a big spark. But if there is no load condition, it's supposed to work under isolators here. It's supposed to work when the power is off. When the power is off. So, which is basically, in other words, no load condition. So the first thing, before turning on the isolator, we need to disconnect the circuit breaker first, then disconnect the isolators. So the procedure, disconnect the circuit breaker first, then disconnect the isolators. So we need to make sure the isolators are being disconnected at zero currents. Otherwise, it will cause some damages to the equipment, which is something that unnecessarily, and we don't want this. Here is how the fuse looks like. This is the fuse. A fuse, or sometimes can be circuit breaker. I'm sorry, it's not a fuse. These are isolators. Apologize. These are the isolators. So our purpose, let's recall on what we discussed before in high voltage lines. We said we need to make sure to do circuit breaker switching off. Then the other thing, isolators. Switching. Is off. But here, after the circuit breaker, we need to do number one first, number two, then the last one, number three. So isolators switch, then do the earth switch. That's what we used to do in the switching. You can recall the switching in high voltage. Then the same scenario with medium voltage as well, or even high voltage. Major equipment supplies. We have ABB, Siemens, GE, Cutler, Hammer, Aton, the Switzer Engineering, then Alstom, Schneider, Areva. This is one of the major supplies, major companies, major switch gear companies. Okay, now I believe we just finished the circuit breaker. Then in the next lecture, we will talk about auto recloser and sectionalizers. That will be the topic of the next lecture, inshallah. Any question? Let me stop the recording.